everyone, welcome. I'm Nikita Singh and you're watching Tech It Out. For decades, technology has tried to mimic the world around us. Today, some of the most ambitious innovations are taking inspiration not just from human intelligence, but from biology itself. In this episode, we'll meet a humanoid robot helping hospital staff care for patients in Italy. We'll also explore a biological computer that uses living human brain cells to perform computing tasks. And we'll see how artificial intelligence is helping grow protein in the Egyptian desert. And we'll look at a robotic arm inspired by one of nature's most remarkable creatures, the octopus. That and more coming up on this episode of Tech It Out. Robots are gradually finding their place in hospitals not as doctors or nurses, but as assistants designed to handle routine tasks and support patient care. In Italy, researchers are testing a humanoid robot called Alter Ego that can interact with patients, share information with medical staff, and help ease some of the day-to-day demands inside a hospital ward. The project offers a glimpse of how AI, robotics, and human expertise could work together in the healthcare system of the future. Here's the story.
Hospitals around the world are increasingly testing robots for tasks that go beyond surgery or medical equipment. The latest example comes from Italy, where researchers are trialing a humanoid robot designed to assist patients and support healthcare staff with routine activities. The robot, called Alter Ego, is currently being tested at Morgari Hospital in Milan. Standing about 1.2 meters tall, the robot features a humanoid design with animated facial expressions, including movable eyebrows that help it interact with patients. The project is a collaboration between the Italian Institute of Technology and the University of Pisa. Alter Ego is designed to handle a range of basic assistance tasks inside a hospital environment. The robot can communicate with patients, guide them through the facility, deliver small items, and act as a remote presence for healthcare professionals. A screen mounted on its chest allows patients to enter information, which can then be shared directly with medical staff.
On
the presence of robot in hospitals, most likely it will help attract young people because seeing technology as a stimulus and a source of inspiration, they will want to be part of that kind of future and reality. So I don't see it as a threat, but rather as an opportunity to improve the way we work in a hospital.
The goal is not to replace doctors or nurses, but to support them by taking over repetitive tasks. This could allow healthcare workers to spend more time on direct patient care. The robot is currently being tested in a department that treats patients with amyotrophic lateral sclerosis, or ALS. ALS is a neurodegenerative disease that affects muscle control and can gradually limit a person's ability to move or communicate. For patients with reduced mobility, a robotic assistant could provide an additional way to request help or access information.
Ego does not take work away from nurses or doctors, nor does it intend to replace people. Ego supports healthcare workers and those who care for patients with ALS.
At present, Alter Ego is operated remotely by a human controller. However, the research team plans to introduce autonomous operation as the project advances. This will allow the robot to navigate hospital spaces and complete certain tasks without direct human control. The development of more capable AI systems is helping accelerate this process. AI allows the robot to better interpret its surroundings, respond to requests, and interact more naturally with people.
All the tasks that are, of course, essential and must be performed, given the nature of the condition, but which offer little added value compared to the interaction and work of healthcare staff.
Despite these advances, healthcare experts say there are clear limits to what robots should handle. Tasks that require medical judgment, clinical decision-making, or direct treatment will continue to remain with human professionals. Instead, robots like Alter Ego are being developed as assistive tools that can support both patients and caregivers. For now, The Milan trial is providing a real-world test of how humanoid robots can fit into modern healthcare settings. By combining robotics, AI, and human oversight, projects like Alter Ego are exploring new ways to deliver support inside hospitals.
The octopus is one of nature's most extraordinary problem solvers. It can squeeze through tight spaces, grip objects of different shapes, and explore its surroundings through touch. Now, researchers are borrowing those same abilities to build a new kind of robotic arm. A team in Italy has designed an octopus-inspired robotic arm that uses artificial suction cups to sense its environment and handle objects in challenging conditions. Take a look.
When engineers want to build better robots, they often look at nature for inspiration. This time, the teacher is an octopus. Researchers in Italy have developed a robotic arm inspired by the sea creature's remarkable ability to feel, explore, and grasp objects. Unlike conventional robotic arms, which often rely on rigid joints and grippers, this prototype is soft, flexible, and covered in artificial suction cups. And just like an octopus, it can use its sense of touch to understand the world around it. Octopuses have long fascinated robotic researchers. Their arms contain no bones, allowing them to bend, twist, and wrap themselves around objects in ways that most machines cannot. Their suckers do more than just grip, they also help the animals sense their environment. Researchers at the Italian Institute of Technology in Genoa wanted to recreate that ability, so they developed a soft robotic arm fitted with sensor-equipped suction cups, designed to explore and interact with its surroundings through touch. Each suction cup contains miniaturized optoelectric sensors. When the cup touches an object, its shape changes slightly. That change affects how light from tiny internal LEDs is reflected back to the sensors. By analyzing those signals, the system can determine where contact has occurred, how strong it is, and even the direction of the force. In effect, the robot is able to feel what it is touching. That ability could be particularly useful in environments where traditional robots struggle: underwater operations, crowded industrial settings, or areas filled with fragile objects.
The robot, in fact, is so soft, so adaptable, like the natural assistant, that can adapt even to very constrained environments to retrieve objects of different shapes, of different weight, adapting its morphology, its behavior to the external environment.
The system also has a modular design, allowing researchers to change the number and position of suction cups depending on the task. The project is part of a growing field known as bio-inspired robotics, where engineers look at millions of years of evolution for design ideas. And the technology may not stop with underwater machines. Researchers believe octopus-like suction systems could one day be incorporated into humanoid robots, helping them handle objects more effectively, especially in wet or challenging conditions.
In theory, we could also think to combine such features in a humanoid, for example, because we could enhance our grasping capability with the suckers from an octopus operating in wet conditions, for example.
Artificial intelligence runs on silicon chips. But what if computers could use actual human brain cells instead? Now, that's a question researchers in Australia are trying to answer with a new type of biological computer that combines living human neurons with traditional computing hardware. The technology has already been trained to play video games, including Doom, but researchers say its potential applications could extend far beyond gaming into healthcare, drug discovery, and machine learning. Here's the story.
Australian researchers have developed a biological computer that uses living human brain cells grown on a silicon chip. The technology has been created by biotech company Cortical Labs, which is studying how human neurons can be integrated with computing systems. These so-called biological computers contain around 200,000 living human brain cells. The cells are grown from stem cells derived from blood donations and are connected to a specialized computer chip known as CL1.
The CL1 system interfaces biology and silicon computing using electricity as a shared language. We pattern that electricity to input information into the cultures and then decode the electrical activity of these neural cells to try and get an answer.
Researchers have now trained these brain cells to play the classic 1990s first-person shooter game, Doom. The experiment follows earlier tests where the same technology was trained to play the simple game Pong. In Doom, the neurons are exposed to a much more complex digital environment that requires exploration, movement, and targeting. Initially, the cells performed like a beginner player, struggling to understand the game environment. Over time, researchers observed the neurons adapting to the digital stimuli and improving their responses. The cells started moving through the game world more effectively and were able to target enemies more regularly.
There's a range of tasks that we've explored, everything from classic Pong to people now doing Doom and Pokemon, even interfacing them with LLMs. But to me as a scientist, the most remarkable thing is to see the beauty of these biological structures able to reorganize themselves and show a rudimentary form of intelligence with such simple structures and yet with such powerful results.
To make this possible, researchers converted the game environment into patterns of electrical signals that the brain cells could understand. When different events occur inside the game, such as an enemy appearing, electrical signals are sent to the neurons through electrodes on the chip.
From this tiny little chip to the computer, they're connected via these electrodes, and then a programmer can never even have to look at these from the cloud and do some Python code and program them and send in electrical currents and see how they respond, and if you can actually teach them to play games like we've shown or learn other types of tasks and do some cool computation that way.
Different patterns of neuron activity can produce actions such as moving left, moving right, or firing a weapon. The research team uses this data to adjust input signals and train the cells to respond more effectively. The experiment shows that biological neural systems can learn from real-time feedback and complete goal-based tasks.
Our neural cultures have been explored for a variety of tasks, including robotics, real-time learning tasks that are similar to AI, as well as healthcare, medicine, disease modeling, drug screening, and even personalized medicine.
The CL1 chip is not designed only for gaming experiments. Cortical Labs says that the same technology could be used in areas such as drug testing, disease modeling, healthcare research, and machine learning systems. Unlike traditional artificial intelligence systems that run on silicon chips, biological computing uses living neural networks that function in a way inspired by the human brain.
The signal comes from the computer, goes through the internet, through this Ethernet cable to our onboard computer, which is hidden underneath here. And then the signal to stimulate or read the activity from the cells goes from the computer to the device, back to the computer, and back through the internet to your other computer, which is where you did your coding, which is where we see the activity, all those really cool things. And people are accessing these devices from all over the world right now, live via the Cortical Cloud, which is pretty cool.
Researchers say the human brain can operate with extremely low energy consumption. The brain uses around 20 watts of power, while modern computing systems require far more energy for complex tasks. Scientists are exploring whether biological computers could eventually offer more efficient ways of processing information. However, the technology is still in an early stage. The cells have a lifespan of around 6 months and currently cannot produce consistent programmable results like conventional computers. Researchers say that the goal is not to replace artificial intelligence, but to develop a different type of computing system that uses the learning abilities of biological cells.
When the war in Ukraine disrupted global food supplies, it revealed just how dependent many countries are on crops grown elsewhere. In Egypt, that challenge has inspired a tech-driven experiment, one that uses AI to help grow protein in the desert. Take a look.
What if protein could be grown in the desert? Well, that is the question driving an Egyptian biotech startup, Al-Protein. Its answer centers on duckweed, a fast-growing aquatic plant, and an AI-powered system designed to monitor, analyze, and optimize its growth. The company believes the combination could help redefine how food is produced in arid regions. The origins of the project can be traced to the shockwaves of the war in Ukraine. As grain exports were disrupted, food importing countries faced higher costs and greater uncertainty over supplies. For Egypt, one of the world's largest wheat importers, the crisis exposed the risks of relying heavily on food produced elsewhere. It also sparked a search for more resilient ways to produce nutrition locally. At a greenhouse northwest of Cairo, duckweed grows in hydroponic beds filled with brackish water. But the plants are constantly being monitored by more than just human eyes. Al-Protein's Orion platform combines sensors, connected devices, and AI models to track growing conditions in real time. The system monitors water quality, environmental conditions, and plant health. The AI can also help detect contamination, predict conditions inside the greenhouse, and identify the optimal time to harvest. The goal is to make food production more efficient while reducing costs and waste.
Detecting, it just detects the contamination sources just in order for us to cut our cost for about 40%, and determining the optimal harvesting time just in order for us to increase our yield production for about 20%.
Duckweed is one of the fastest growing plants on Earth. It can double in size in just 24 hours, requires very little land, and can grow in brackish water that many conventional crops cannot tolerate. Al-Protein is now using it to develop protein ingredients for food products, including plant-based proteins and dairy alternatives. For regions where arable land is scarce, that could open up new possibilities for food production.
We take our products to serve into take our cultivated lentils to serve the three products that we're very proud of in MENA region and Europe. To then have it all as decentralized protein nodes in the desert, from farm to fork.
Al-Protein calls its vision protein nodes in the desert. Small production hubs designed to grow high-protein crops in regions with limited arable land. The company believes AI will be critical to making that model work, helping monitor conditions, reduce waste, and improve yields. In a country dominated by desert, the project is testing whether technology can help turn some of the least farmable land into a source of protein.
This week, we looked at machines becoming more human-like. Robots that can assist in hospitals, computers built using living brain cells, and engineers borrowing ideas from nature to solve complex problems. Now, as remarkable as these advancements are, another frontier is advancing just as quickly. Researchers around the world are working on technologies that could allow people to control computers directly with their thoughts through brain-computer interfaces. Now, the science is still in its early stages, but if it succeeds, the boundary between humans and machines may become far less distinct than it is today. On that note, I'll take your leave. Keep watching WION World is One, like us on social media, and have a great weekend. Until next week, bye-bye.